All right, everybody, we're going to be talking about end behavior today in polynomial functions. Here we have a polynomial function right here. It says consider this function, and we have q of x equals negative 2 x to the power of 8 plus blah, 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 all the way to the end. So we got to figure out what the heck the end behavior of this particular graph q is. So here's what I'd like you to do, okay? I would like you to go to your document that has this table right here. This is a beautiful table, and it talks to you guys about end behavior with different types of functions. Now, something we talked about in the past is what an odd versus an even function. Well, this is not what it's talking about. This is talking about an odd degree function or an even degree function. So all odd degree functions that are positive will have this end behavior. So what would that be? And I'll write some examples here so you're like, what the heck are you talking about? So for example, if I said f of x equals x, or f of x equals x to the power of 3, or f of x equals x to the power of 5. No matter, that's a 1. No matter what it is, as long as it's an odd exponent and this is positive, this is what the end behavior will look like. Okay, so let me show you a quick little example so you know what I'm telling you is the truth. All right, so let's go over here to Desmos and we'll go ahead and just type in x. Then we'll go and we'll do x to the power of 3. Okay, and then we'll go and do x to the power of 5. Hopefully you'll trust me after that this is the pattern here. No matter what, even if I add something ridiculous, okay, so put minus 2x or minus 2x to the power of 4. All right, no matter what it looks like, if we zoom out, the end behavior, it starts out from the left and it goes to the right. So what does that mean for us? That means as the graph is going towards negative infinity, the y values are also traveling to negative infinity. All right, so if we look at this right here, it's saying as x approaches negative infinity, my y values is going towards negative infinity. Over here it says as x is approaching positive infinity, f of x is also approaching positive infinity. And so that's going to be the pattern for if it's an odd degree. So key word is the degree. And when I'm referring to the degree, I'm referring to this number right here, and it's positive. So what happens if we change it to an odd negative? So let's say I go over here and I put f of x equals a negative x, or f of x equals a negative x cubed. Sorry, I'll put that right over the word multiplicity, but let's pretend there's a 3 right there. Or I say f of x equals negative x to the 5th. All right? If I do that, then this is what the function's going to look like. It's going to start from the left, it's going to go down from left to right. That's what's going to happen. If you don't believe me, check this out. We're going to take that, put a negative. Over here, we're going to put a negative. And then over here, we're going to put a negative. And you see, if we zoom out, that all those graphs go down from left to right. Now, this obviously the red one's a little bit easier to see. All right, but they all go down from left to right. So, what does that mean for us? Here's what it means. If I see a function, no matter what it is, all right, if I see a function that says f of x equals 2x cubed minus 2x squared, I know the end behavior is going to follow this pattern. But if I see a function on this side and I see a negative 2x to the power of 5 minus 4x squared plus 7x, all I got to really worry about is what does this tell me? This tells me everything I need to know, just like this tells me everything I need to know. This number is positive, that number's odd. This number's negative, that number's odd. So that's where it talks about odd and positive and odd and negative. So over here, if we take a look at even and positive and even and negative. If I had an even degree function, that means the exponent has to be even. So here's an even positive. Give me any positive number, say 4, and I say x to the 4th minus 3x squared plus 2. Automatically, I know no matter what, it's going to end up looking like this. The end behavior is going to be finishing at positive infinity and positive infinity. Whereas, if I had a function and I had a negative coefficient, like a negative 2, but it was still an even degree function, like an x squared minus 3x plus 5, all I'm focused on is this portion right in here. So this tells me everything I need to know. It's negative and it's even. Here it's positive and it's even. So I know what the end behavior is going to look like. So how do we write end behavior one more time? All right, this is how you write end behavior. Let's take a look at this even one. It's basically saying as x is approaching negative infinity, which means as my x values are being plotted to the left, what is f of x approaching? Well, f of x is approaching positive infinity. But as x is approaching positive infinity over here on the right, what's happening to all of my y values? They are also approaching positive infinity. And that's how you read end behavior. If you're wondering what this little arrow means, it means approaches. Approaches, just like that. Okay? So, if you don't believe me, check this out. It's really cool. So let's take this and let's take away these negatives, right? Take away the negative, and take away the negative, and take away the negative. And let's change this to an exponent that's even, and then we're going to change this to an exponent, okay, that's even. Then we're going to change this to an exponent that is no, not odd, even. There we go. Now I'm going to put some fractions in front of this just to make it a little bit easier. So I'll put like 1 divided by 10. So you can at least, it'll stretch it out. Let's do 100. Oh, not 0. Let's do 100. We'll stretch it out. And then over here, we'll do like 1 divided by 1,000. Oh, how about this? 100. 100's fine. Okay? And then over here, we'll do 1 divided by 10. There we go. All right? So no matter what, if we zoom out, no matter what, you can still see that it's opening up, which is just like all of these. So what does this have to be? This coefficient has to be positive, and this has to be an even. But what happens when I make it a negative? I make that a negative, and I make that a negative, and I make that a negative. What happens? They all open what direction? They all open down, and it follows this pattern right here. And that's all you need to know about odd degree and even degree functions for end behavior. It's really easy. It's pretty awesome. So, are you guys ready? I'm ready. I don't know about you. I'm pumped. I'm excited. Here we go. Let's go to our assignments. There we go. Now, what are we going to look at? We're going to look at this right here, and I said I'm going to highlight it. So right here, we're going to highlight this guy right here. You guys see that says -2? So it's negative, but it's even. So negative and even, that's going to follow this one right here. So what happens? All of my y values are traveling to negative infinity. So that's all I'm looking for. I'm looking for the answer where all the y values are traveling to negative infinity. So no, that's positive. That's negative. That's good. Oh, that's positive, negative. I'm looking for negative, negative. There we go. So as x approaches positive infinity, q of x approaches negative. As x approaches negative infinity, q of x approaches negative. So I know my answer is going to be C, because it follows that pattern. All right, go ahead and select it. Boom, got it. All right, here we go. Let's look at this one. Ooh, that's negative, and that's even. So dadgummit, it's the same answer. So negative, everything's going down. Yep, so here we go. As x approaches positive infinity, y is going to negative infinity. As x approaches negative infinity, y is going to negative infinity. And it's going to be the same answer because that's negative and that's an even. So we'll do it. We'll do another one. Because that one just wasn't, hold on, I'm better pause real quick. All right, here's a better one. All right, so right now, let's check it out. We've got right here, we've got a positive even. Now, positive even, That's dealing with this one. See, positive and even. So where's it going? It's going up to say Jesus right here, going up to positive infinity. All right, so we're just looking for everything being positive. Everything positive. Okay, so as x approaches positive infinity, y approaches positive. Good. As x approaches negative infinity, y approaches positive. So I'm going to go A, because everything's going up no matter what. It's all going up. It's all good in the neighborhood. All right. Boom. All right, here we go. Finally, an odd degree function. Perfect. This will be the last one that we do, okay? And then you guys can hopefully work on it on your own. Oh, hold on. There we go. So if you're wondering, what is he talking about? Positive and odd. You are so odd is what you're saying. So that's a positive number. That 3 is a positive, but that degree is odd. So what pattern does that follow? Odd and positive. So as it goes to negative infinity, it's going down. But as it's going to positive infinity, it's going up. And that's what we're going to do. All right, so as it's going to negative infinity, it goes down. Nope. At negative infinity, nope. As it goes into negative infinity, it's going down. That's good. But it's got to be going up to positive. Oh, looks like it's going to be answer choice D. As x approaches positive infinity, h of x approaches positive. That's good. That's what we want. As x approaches negative infinity, y's are going in. That's the one we're looking for. Why are we looking for that one? Because that's the one that follows this pattern right here. Okay? And by the way, LIM just means limit. The limit of f of x is negative infinity. And I think that's about all I have. Hopefully, by me getting these right over and over and over again, you will trust me. Once again, we've already done this one. This is positive and it's even, so it opens up. We know it opens up. So you're looking for something that has positive infinity and positive infinity. I'm not going to tell you the answer, but it's looking like this is going to be my answer right here. All right, I'll stop. So hope you guys have a wonderful day. Hope you learned about end behavior. All right.